Hey, on your practice test, don't forget your name. Now, on the first question, or the first two questions, I want you to find the vertex, 2 points to the right of the vertex, 2 points to the left of the vertex, then graph the equation. So I want to see your work. So to find the vertex, remember it's negative b over 2a. And on this problem, a is negative 2, b is negative 3. So we said the opposite of negative 3 all over 2 times negative 2. Well, the opposite of negative 3 is 3. And 2 times negative 2 is negative 4. So we know our vertex is going to be at negative 3/4. And since it's a fraction, it's not going to be, it's kind of hard to count your fraction to be the same distance unless you want to use all fractions. And I think it's easier to make the table than it is to figure out, to count by fractional forces. So we're going to go negative 3/4 is our vertex. So if I go to the right of negative 3/4 in the number line, my first whole number would be 0 and 1. I can definitely see my y-intercept is 3. So I can grab 0 and 1, 2, 3. And then to the left of negative 3/4, I'll go negative 1 and negative 2. I think I'll make a table. I'll use the table function in my graphing calculator to fill in my table. So what I'll do here is, let's make a table. And when you make your table, instead of typing in y1, we're going to type in our equation, which is going to be negative 2x squared. And notice we have this x1. So we're going to go negative 2x1 squared. And then we'll do minus 3x1 plus 3. So minus 3x1. Whoop, I put in 2 ones there. And then, what did we say? Plus 3. And so my graph is going to start at negative 2. And then I'll go negative 1. Then I'll put in my vertex, which is negative 3/4. And I'll go 0. And I'll go 1. My points aren't equally spaced, but you can still see the parabola there, can't we? So at negative 2, I'm up at 1. So when I go to the left 2, I'm up at 1. And then when I'm at negative 1, I'm going to be up here at 4. 1, 2, 3, 4. My vertex is going to be at 4.1 about. So negative 3/4 and 4.1. That's my vertex. And then I might as well plot when I'm at 1. I'm at 1, I'm going to be down here at negative 2. Barely fits on my graph. So my graph, I didn't draw that one there we go. I didn't quite get the gist of it, but we get it kind of close. There we go. Now, we're going to do the same thing on number 2. Notice in number 2, A is 3 and B is negative 5. So x equals negative B over 2A. So the opposite of negative 5 all over 2 times 3. So it'll be positive 5 over 6 is giving me my vertex. So here I have 5, 6. So the left of 5, 6 of the number line is going to be 0 and negative 1. I can see my y-intercept is at negative 2. So go down here, 1, 2. Okay, then I'll go 1 and 2. And I think I'll make a table for this one too. So I'm going to go 3x squared minus 5x minus 2. And let's make a new graph completely. So, and I'm terrible at remembering. I think it was 3x squared. Don't forget your 1. And then minus 5x minus 2. So minus 5x1 minus 2. And then my graph starts at negative 1. So I go negative 1. Probably don't need the 0, but I'll put in 5, 6 then. And then I'll go 1 and 2. So negative 1, I'm going to be at 6. So to the left, oh, I'm way off the graph there, aren't I? So a negative 1 is way up too high. Okay, 5, 6, I'll be at negative 4.1. And then over 5, 6, here's 1, 2, 3, 4.1. And so I know my graph is going to look something like that. Let's fill in the points in my table because I want to say it, follow the directions. So I got negative 4.1. 1 is going to be at negative 4 and 0. And I didn't draw that very well, so let's regraph that. So negative 1 is off my chart, but 0 is going to be at negative 2. 5, 6 is going to be at negative 4.1. 1 is going to be at negative 4. And 2 is going to be at 0. So now I can do my parabola. There we go. That looks a little bit better. Now we've got our 3 points. 2 points to the left of the vertex, our vertex, and then our graph. And that's what you would do to graph these on your test. I don't want just the graph. I want to see 2 points to the left, 2 points to the right, and the vertex.